In this video, we will introduce our work, Articulated Object Manipulation with Coarse-to-Fine Affordance for Mitigating the Effect of Point Cloud Noise. Recently, point level affordance, which predicts the per-point actionable score and thus proposes the best point to interact with, has demonstrated excellent performance in articulated object manipulation. However, a significant challenge remains. While previous works use perfect point cloud generated in simulation, the models cannot directly apply to the noisy point cloud in the real world, known as the sim-to-real gap. Such performance degradation mainly comes from two reasons. First, the model does not have the robustness to the out-of-distribution noisy point cloud in the real world. Second, the important geometries for manipulation, such as handles, may face heavy distortions, cannot be reflected from the noisy point cloud. To mitigate the effect of point cloud noise for manipulation, we leverages the property that the extent of noise will decrease with the distance decrease between the camera and the target object, and introduces a coarse-to-fine affordance learning framework. Our framework consists of three modules. The coarse module takes only the far point cloud as input, extracts per point features using PointNet++, and then predicts per point coarse affordance map. Despite the far view tend to receive much noise, it also captures crucial global information for selecting a nearer viewing position for closer inspection. After moving the camera, mounted on the gripper to the estimated manipulation area, the fine module takes the near point cloud and predicts the feasibility of each. The near view faces much slighter noises and preserves the geometries of objects. Lastly, the actor module outputs an action set for each point in near point cloud for manipulating the object. Besides, only taking the fine point cloud to propose actions possesses a limitation that it disregards global context, such as the direction of Dr. axis. To address it, we introduce an integration between the features of the coarse point cloud and the fine point cloud. Using the SAP IEN physical simulator and the PartNet mobility dataset, equipped with a ray tracing depth camera that generates noisy point cloud with the same principle of real-world sensors, our experiments rigorously evaluate our approach. To verify our method's real-world applicability and its ability, we conduct real-world experiments using a 7DOF Franca Imika Panda robot with a RealSense camera mounted on its hand. We sequentially capture far and near point cloud to generate the affordance map as the object-centric representation, which provides us the manipulation point and interaction direction. The point with highest score is shown yellow. To achieve long-term manipulation, we employ a heuristic method to sequentially output the next action and execute it with Cartesian impedance control, which transforms the end effector action to the commanded joint force for the Franca Panda robot. Please refer to our project page for more details by scanning the QR code below. Thank you for watching.